Sports writer Grantland Rice once wrote, "It's not if you win or lose, it's how you play the game." But you can't play the game, any game,
Every move.
from baseball to basketball, from cards to kayaking, unless you know the rules.
What did you really add to the right side? I've got
And the same applies to
I
algebra.
got the -1 out front. So the question is, what do I need to add to the left side to balance it?
In this module, you'll learn about the order of operations in symbolic forms and the rule of distributive property.
What do I need to put in here to get 0 for y? Wrong. Check on the calculator.
Rules help math to be consistent and therefore to make sense.
So I'm going to...
And these rules can be applied to symbolic forms to help make
I'm at
playing the
211
game
for my vertex,
more efficient.
So I'm up here. Now, what?
So in the game of baseball, here's how the rules of algebra apply. An important number used to judge the performance of a pitcher is called an ERA, earned run average.
To deep left field, and Gaetti has hit it out.
It tells, on the average, how many runs a pitcher allows in a typical 9-inning game. The earned run average is the number of runs, except those caused by errors, scored against a pitcher divided by the innings he has pitched, then multiplied by 9, the number of innings in a game. If a pitcher allows 20 runs in pitching 100 innings, the earned run average is 1.80. This means that the pitcher allows fewer than 2 earned runs per 9-inning game, which is a very good earned run average. The rules of algebra tell us that the earned run average can also be calculated in another way. Replacing the runs scored with 20 and innings pitched with 100 gives the same result. Often, algebra is used to change the way in which a calculation is done in order to make it easier to understand. Unless the person doing the calculation obeys the rules of algebra, the result will be incorrect. Since the rules of arithmetic also apply to algebra, you're probably already familiar with some algebraic rules. For example, multiplication and division are done before addition and subtraction. Calculations inside of parentheses are done first. Now, how can the language of algebra help to manage a burgeoning mountain of trash? This is probably a familiar scene, one that's becoming commonplace nationwide. Concern about the environmental impact of dumping or burning trash has motivated many communities to begin recycling programs. Separating reusable materials from plain old garbage can actually bring down the overall cost of trash disposal. So recycling makes good environmental sense and good financial sense as well. This recycling collection center has a basic operating rule. Residents must separate materials into specific groups: plastic, glass, metal, paper. The cost to the town of hiring workers to do that job would be too high. Cities and taxpayers see recycling as a good idea when it doesn't cost more than other disposal alternatives. When everyone follows the rule, there's a real benefit: money. Money that comes from selling the reusable materials. So far, so good. But where's the algebra? Since proper record keeping can make the difference of whether a recycle program is successful or not, algebra is a useful tool for performing the many calculations necessary. Suppose that the price per ton of scrap metal is represented by the letter P, and that a recycling company collects 5 tons of scrap metal from a town. Then the value of scrap metal is found by multiplying 5 times P. Multiplying by 5 is the same as adding 5 P's in succession, so 5 times P is usually just written as 5P. Another reason for omitting the multiplication sign is that it can be confused with the letter X, which is often used to represent a variable. So the value of the trash is expressed as V equals 5p. Of course, if we want to find the value when the price of scrap metal is $7 per ton, we must use a symbol for the multiplication so that we don't confuse 5 times 7 with 57. Now suppose the recycling company collects 5 tons from one town, 8 tons from another, and 12 tons from a third. The total value of the trash is V equals 5p plus 8p plus 12p. If the price is $7 per ton, then the company can find the total value of the scrap metal collected from all 3 towns. Remember that the rules of algebra say that all multiplications are done before additions. An important algebraic rule allows this calculation to be done more efficiently. It's called the rule of distributive property. In this symbolic form, the individual parts, 5p, 8p, 12p, are called terms. The rule allows us to use addition or subtraction to combine terms that have the same variable. In other words, whenever we multiply several numbers by the same variable, p in this case, and then add or subtract the results, the multiplication by p can be performed only once instead of 3 separate times. So, to find the total value of the scrap metal, the recycling company need only multiply the value of p by 25. In this module, you've learned the meaning of the order of operations in symbolic forms, the rule of distributive property.